Good morning.
Good morning, sir.
Good morning. So, which class you had first hour? Which class you had? Mechanical. Why sir left late? Yes, Manasa. Why sir left? Why you had joined the meeting late? Yes, anyone? Am I audible?
Sir was discussing about ISF, so he took some more.
Okay. So, do you remember what we were discussing in the last class? Can anyone tell me what we were discussing in the last class? Yes, anyone? Yes, Rahul, Prajwal, Kusuma. Can you just tell me what we were discussing in the last class? Yes, anyone?
Excuse me, sir.
Yes, Pushkar.
Good morning, sir.
Good morning, Pushkar.
Sir, actually, I want to say now that in the flip-flop, sir, we are having a kind of problem, sir.
What problem, Pushkar?
Actually, sir, the inputs and
Pushkar, you have been muted. Tell me.
yes, sir. Actually, sir, the input and the output relations, it quite confusing.
Okay, what we will do it, Pushkar. Today we will try to complete this. Okay, so tomorrow
Yes,
we will, and once again we recollect or we will brush up the flip flops.
Tomorrow we'll do the revision, right, sir?
Tomorrow we will do the revision.
Okay, sir. And one more thing, sir.
Yes,
Sir, that assignment date, sir.
Yes,
Sir,
Pushkar.
explain it, sir, please.
Okay, I will extend it. I will extend another 4 days. Shall I give extension?
Sure, sir.
Okay, then I will give you another 4 days. So after the internals, when your internals will be over, Monday, Tuesday, Wednesday, Thursday it will be over, or when?
It will be Wednesday, sir.
Wednesday it will. Okay, I will give you on Friday. Okay.
Yes,
Okay.
sir. Thank you.
Okay. Then, is any doubts you have? Anything? Is anyone? Yes, tell me. Anyone? Yes. Okay. So yesterday, what we were discussing, can anybody tell me? We were discussing about a rectifiers. So we were discussing about a half-wave rectifiers. So can anybody tell me what you mean by half-wave rectifier and why we have done and what is the mathematical analysis we have done in the previous class? Yes, anyone? Yes, anyone? Yes, Kishore. Yes, Manasa is here. Yes, Manasa. See, you should talk because when we talk only, we will try to learn more instead of when we keep on listening. So if you talk, then if you exchange some information, then you will be learning more rather than just continuously listening. Miss, tell me what you have understood from the rectifiers. So still whatever we have done, right? So what are the things you have learned or what are the things you have understood from till now, still today's class related to the module number 1. So let us only talk about only the rectifiers. Yes. Is anyone? Yes, Monica is here. Monica, absent. Okay, Sugandhashree. Sorry, Gunasundar. Gunasundar is here. Gunasundar. No, absent. Yes, Gunasundar. What we were discussing in the last class, can you just brief about it? What you learned or what you understood? What are the terms you heard? You just tell those. That's all. Don't remember anything in the yesterday about the yesterday's class? Yes, Manoj. Nivedita. Yes. Yes, Nivedita. Yes, who is going to tell me what and all we were discussing in the last class? Yes,
So,
Nivedita. Yes. Yes, Nivedita. We were discussing about a half wave rectifiers. Yes, in that, Nitin, what exactly we were discussing?
So we discussed about the definition of that half wave rectifier,
Okay.
which converts the half wave of the AC to DC, sir.
Yes, very good. And then what and all you have learned, Nitin? Yes.
So then we get that the voltage, the input voltage in the that is V is equal to Vm sin theta,
Okay.
and the current we get as an output is I equal to Im sin theta, sir.
Okay, very good. Yes, then.
Im Vm.
Yes. What do you mean by that IM and VM, Nitin?
Sir, Im is the max current and Vm is the max voltage, sir.
Okay, very good. Yes. So what is the input for the rectifiers? Can anybody tell me what is the input for the rectifier? What we are feeding the input to the rectifier? Yes, anyone? How you represent the input signal? Yes, how you represent the input signal? Yes, Pushkar, are you here? Pushkar? See, the thing is, see, this is the first module and means the initial stages, no, you should be very attentive in the class. So if you're not attending, if you're just simply turning on the video and if you're not listening means then it will be difficult for you people. Okay, so because the first module, fifth module, those are the conceptualized modules, you need to study them well. It's not only for the basic electronics, it will be helpful for your the third semester subjects also. Means there is a correlation is there. Okay, it's your and as I told you repeatedly, I'm telling you, it is not the subject that you need to study only for the this semester and leave it means you will not be applicable for rest of the semesters means that is not the right way of looking the subject of this basic electronics. Okay, it is very essential in order to know the basics of the electronic component. See, whatever the design or whatever the coding we will be writing, it has to be done from the electronic equipment only. So it is necessary for us to know what are the basics things which are there in the basic electronics and how the communication has been established between the two entities. Means then you need to study this basic electronics with full extent. Okay, so since because of the internals, I wanted to complete the syllabus. So I was not pinpointing the each student whether you are able to understanding or whether you are following or not. So once this internals get over, then I will pay attention for each student. So if you're not attending the classes punctually or if you're not listening, okay, don't talk. Yes, okay, I will not talk about any listening act whether you are active or not. Whatever the questions I will be asking you or whatever the concepts we will be completing, I will ask some questions based upon that. If you are ready to explain or if you are very good enough to tell me those explanation means then it's enough for me. It's not that from my end only you need to learn. It is not the thing. So however is possible from your end, if you're learning the things means then that is well and good. Is that clear to everyone? Yes? No? No response. Isn't it?
Clear, sir.
It's clear. Okay. Okay. So let me share the notes. Okay. See, in the yesterday's class, I told you the half wave rectifier. So half wave rectifier, as I told you, basically what you will be giving an input signal. You will be giving an input signal. It is a AC. So you can see the AC will be represented in this manner, a sinusoidal signal. So for this, what you are giving a diode. You are giving a diode. Okay. So this diode you are applying to some external entity or where you want to take the output. No. So that we call it as a load, we call it as a resistance. Generally load will be resistance the value. Okay, now what we will be having is, so this will be your RL and this will be your resist, that is a diode. Okay, and this will be your input source, that is your V in, that is your V in. Okay, I told you V in how we will be representing, that is V in is nothing but it is a sinusoidal signal, so it will be having amplitude and frequency or phase component also. Okay, so what is that? It is nothing but Vm into sine omega t. Vm into sine omega t. What is this omega? It is an angular frequency, we call it as, and t is a independent variable. Okay, so Vm is the amplitude, sine omega t is the angular component of this. So generally this, what is this? Omega is nothing but it is a 2 pi f. It is a omega is nothing but 2 pi f, where f is nothing but operating frequency. I told you Vn, it is nothing but it is a sinusoidal signal what you are receiving from your home. That is nothing but generally it will be 230 voltage and a 50 hertz frequency you will be having, and a 50 hertz frequency you will be having. So this is the frequency what we are pointing at over here. Okay, so now what happens if I pass this signal? If I pass this signal, let us say if I pass this signal to the diode what I have called a circuit what I have represented. Okay, so what I have represented the input signal, right? It is a sinusoidal signal. So you can see here the sinusoidal signal start with 0 amplitude. It will increases and again it reaches to the negative value and again it will increases. So like this will be in the sinusoidal manner. Okay, so this we will be representing in terms of omega t. That is the angular frequency we will be representing. So what is this initial value? This will be 0 and this will be pi and this will be 2 pi. So means the fundamental frequency. Why it is called as a fundamental frequency is 2 pi? Because the cycle is repeating. You can see here the first cycle between 0 to 2 pi and 2 pi to let us then it is called as a 3 pi and then it is called as a 4 pi. This is called as a 4 pi. So the fundamental period, the repetitive cycle when it is taking from 0 to 2 pi, from 2 pi to 4 pi. So therefore the fundamental frequency of this Vn we call it as a 2 pi radians. Always it will be represented in terms of radian, that is r. Omega t will be represented in terms of r. So as I told you, what I told in the yesterday's class is, so when the input signal is applied to the circuit, what I have shown to the above, during positive half of the cycle, so the diode will conduct. So means what? The diode will be short circuited or it will be replaced with the short circuit. Now you can see the short circuit, the current will flow across this. So because of the current which is flows across here, you are measuring the voltage across this R terminal. We are measuring the voltage across this R terminal. Thus we call it as a V naught. Okay, so if I measure the V naught or current I naught over here is, so as I told you, this is nothing but the input signal, the maximum voltage or we are getting, or the in the negative direction whatever you are getting, right? So that we will be representing in terms of Vm. So this is your input voltage. Either you can call it as V or you can call it as a Vn, anything you can call it as. So when I pass this signal to this circuit diagram during the positive half cycle, what happens is the diode will conduct. So whatever the input signal is there, right? So that will be appeared. Whatever the input signal is there, right? So that will be appeared. So therefore, what happens during 0 to this half cycle of the input? So sorry, just wait a minute. Okay, so during this, what happens is during this half cycle, so the diode will conduct. Okay, so what happens? The diode will conduct. You'll be getting a waveforms like this across the output terminal, that is nothing but V output or V0. Okay, so the maximum amplitude what we'll be getting is we'll be getting a Vm only. Now what happens during the negative half of the cycle, means during this cycle the polarity will change. The minus will be applied and plus will be applied. The diode will be reverse bias. In such condition, the diode will act like a open circuited. When it is open circuited, current will not flow across this RL. So the current will be 0. So 0 into VL, you will be getting 0. So therefore, you will not get any waveform across over here. Again, when the input signal will comes positive values, so again the diode will be forward bias. So you'll be getting a value and here it will be 0. Okay, so this is, we call it as a V output. Now this has to be analysis, and I told you we will be measuring two important phenomena, that is nothing but we will be measuring one, that is VDC and IDC. We will be measuring one important calculators, that is a factor, that is nothing but VDC and IDC. So what is this VDC and IDC? We call it as a DC currents or DC voltage. We call it as a DC voltages, or we call it as a DC current. DC voltages or a DC current. So why you call it as a DC voltages currents? Because the aim of our rectifier is to convert the AC into DC. So how much percentage of DC we are expecting, or how much current of AC we are expecting, we need to note it down. Okay, so therefore what, so generally, so if I write an DC signal, an actual DC signal, if I write, means it should be independent of the operating frequency. Okay, means the frequency should not be there, it is to be zero actually. Okay, so if I say write an DC signal, means it should be like this. This is an DC signal. So you can see here, whatever may be the time variations, the input voltage should not say, let's say it is called as a 1 IM, I will call. I will call. Okay, so the DC signal, it has to be, means it should be in this manner. But what you are getting, whatever the output you are getting now, so how you are getting the output? So you are getting the output something like this. You are getting the output something like this. So like this, you are getting the output. You are getting the output. Okay, so means what? It is not a perfect DC signal. It is a pulsating DC signal. We call it as a pulsating DC signal. So in this pulsating DC signal, we need to know what is the average DC I will be getting. What is the average DC? So if I do the average over one fundamental period, if I do one average over one fundamental period, that is nothing but 2 pi. So what is the average value I will be getting? I need to check. So for that, what we have used is, we have calculated VDC and IDC. We have calculated VDC and IDC. Okay, so that is the first thing what we have calculated. Next, what we have calculated? We have calculated again AC signal, that is a RMS value. We have calculated RMS value. So what is this RMS value? I told you. Yes, can anybody tell me what you mean by this RMS value? Anyone? What is the expansion of RMS signal, RMS value? Yes, Manish? Yes, okay. Root mean square. Yes, why it is required? Yes, can anybody tell me why it is required? Anyway, we have already calculated the DC value, but why we need to calculate this? Yes, Nitin, any guesses? Nitin, yes, any guesses? Why we need to? Yes, Nitin.
Sir, I think to get a stable current.
Once again, repeat, Nitin.
Sir, I think to get a stable current in amps, sir.
Stable current in amps. Okay, any other try? Any other students? Yes, Pushkar, any other try? Why it is required for us to calculate this RMS value? Is anyone? Okay. So somewhat what Nitin has said, it is correct. So RMS is nothing but a root mean square current. See, why we need to calculate this RMS current is, say especially this RMS current we will be calculating for the AC signals. Okay, so since the output what you have got, it is something resembling like a AC signal. So it is necessary for us to know what is the RMS current or RMS value in the AC signal. Okay, so for let's say one fundamental example, let us try to give. What is this? So let us consider an signal is I am applying over here. Okay, so if I take this signal over the fundamental period 2 pi. Okay, so if I take, let's say I want to take the average value of this. If I want to take the average value of this. Okay, so what happens? See here, from here to here it is positive value. From here to here it is negative value. So if I take the average, what you'll be getting? So the positive value minus negative values you'll be getting. Okay, even though if you add it, you'll be getting minus whole divided by 2. So what you'll be getting? You'll be getting the average is equal to 0. Okay, so but there is a component is there, there is a signal is there, but if I want to measure the average value, means it is not possible for us to do it. Okay, so therefore what we do is we go for an RMS value. So it tells how much of current or how much of voltage is there in the given signal. So therefore we go for an RMS value. So why we need to go? So as I told you, when I want to measure the average value, positive minus it is giving 0 value. So what I will be doing is I will square them values. So whatever the positive value is there, so I will square them. Okay, I will square them. Okay, and whatever the negative value is there, so I will square them. Okay, and then what? I will take the average of that because we are doing a average means over the one fundamental period we are doing. So I will average that. Okay, so now what? Since you have squared it, you can see you have squared it. So it is necessary for us to take the square root of this. Okay, so therefore I will take a square root of this. So when I do that, you'll be getting the actual current or voltage which is there in the given signal. So therefore, we will try to calculate this RMS value for the AC signal. RMS value for the AC signal. So why it is called as a root square mean value. Root square mean value. Are you able to understanding why I am telling this RMS value important? Anyone? Yes, Arpita, did you understood this? Did you understood this?
Oh, yes, sir.
Okay, so we are using that mechanism in order to see this RMS value. Okay, so we have calculating this RMS value in this class. Okay, so now let us see what we have done in the previous classes now. Okay, so now we can see here I have calculated I have used a mathematical expression that is nothing but V in is equal to Vm sin omega t. So the omega will take in the range of 0 to 2 pi. Why we are considering only 2 pi? Because it is a repetitive cycle. If you further analysis the same thing, you'll be getting the same thing. So now what we want to do is during the positive half of the cycle, so what is a load voltage or what is a load current you are getting across the load terminal? If we calculate this, you'll be getting IL is equal to Vm divided by Rf plus Rs plus RL into sin omega t. So since I told you yesterday, the forward resistance and the secondary coil resistance, it will be very less when you compare to the load resistance. So therefore, we will try to minimize this effect over the RL. So if I do that, you'll be getting RL is equal to Im sin omega t. Okay, so where Im is nothing but your Vm by RL. Im is nothing but your Vm by RL. So in the negative cycle, what I told you, since there is no current will flow across the diode, so your IL will be 0. So therefore, your current which is across the load, it will be 0. Okay, so next I told you it is necessary for us to measure the DC values. So how you will be measuring the DC value or average value? It is nothing but the current in the one fundamental period divided by what is the period you are taking it over here. So in order to know the amount of current in the given period, we will be using the area under the curve. So area under the curve, and what is the time period? The time period what we have taken is we have taken it as a 2 pi. Okay, so therefore we have taken a time period is equal to 2 pi. So this is the time period and this is the area where the current you are expecting or where the current is there. Okay, so this area what we are doing, we are dividing into positive half cycle and a negative half cycle. We are dividing into positive half cycle and a negative half cycle. And we know that the negative half cycle is 0. Why? Because there is no current. So therefore the negative half cycle is 0. Okay, in the positive half cycle, we need to do the we need to apply the integration. So therefore, it is 0 to pi Im sin omega t into d omega. So Im is a constant. So I'll be taking it outside. So what we'll be getting is Im divided by 2 pi. And we know that sin omega t integration is minus cos omega t. Okay, so since you have a values over here, you have a values means limits you have. So the lower limit is 0, upper limit is high. So what you're supposed to do is you need to substitute the higher limit first and then you need to substitute the lower limit second. Okay, higher limit minus lower limit. So cos pi minus cos 0. So we know that cos pi is minus 1 minus cos 0 is 1. So minus 1 you'll be getting minus 2. So therefore what you'll be getting anyway you have a minus 1 already is there. So minus minus will become plus Im divided by 2 pi and this 2 you have got. So now what happens? This 2 and this 2 will cancel it out. So the DC current which is flowing across the half wave rectifier, it is nothing but it is a Im by pi. It is a Im by pi. Okay, so this is what we have discussed. Okay, so the next thing. So effective RMS value we need to calculate. So I told you, right, it is a square root of the average value what you are taking under the area. It is a square root what you have taken under the area. So now what we have done is, so I am substituting the IL expression that is nothing but Im sin omega t. So I square sin square omega t into d omega t. Okay, and anyway the second negative it is 0. So it is a negative cycle, it is 0. Okay, so now what I'm trying to do is I'm making a trigonometric substitution. What is that? Sine square omega t is nothing but 1 minus 2 cos omega t divided with by 2 I am doing. So 1 by 2, it is nothing but d omega t will be getting integration. And here cos omega 2 is nothing but sine omega 2 wt divided by 2 you will be getting. Okay, so you're substituting the upper limit and lower limit, upper limit and lower limit you are substituting. So if you do the substitution, so what you'll be getting is finally, so the RMS value, the current value RMS will be getting a IM by 2 you will be getting. Okay, IM by 2 will be getting. So once we know that, the next thing what we need to do is we need to calculate the power which has been dissipated, the average power, that is a DC power which has been dissipated across the load resistance RL we need to know. Okay, so can anybody tell me what is the power equation? How you calculate the power equation? Is there any equation is there to calculate the power? Yes, anyone? Yes, anyone?
So VI,
Sir,
Yes,
I am
voltage into
yes, yes. We can use either V into I, or we can use that V square by R. We can use that I square into R. Okay. So these are the things what you can use. So we need to calculate this PDC. So if you want to use this PDC means what? You need that is nothing but VDC into IDC you need. VDC into IDC you need. So we got IDC, but we don't know what is PDC, right? VDC, right? So therefore, we can write this VDC is nothing but IDC into RL. So what is this VDC? Is the voltage across the load. So how I can write the current across the load? So what is the current across the load? DC into what is the resistance? The resistance is RL. Where you are checking the voltage, you are checking at the voltage across the resistors. So therefore, I am substituting VDC is equal to IDC into RL. That is the way you want to measure the IDC value. So therefore, you will be getting VDC into IDC. Okay, so if I substitute that, just how I calculated what is this IDC? That is Vm by pi into RL. So if you substitute, so Vm, this RL and this RL will cancel it out. So you're left with VDC is equal to Vm by pi. Similarly, so what you have learned, IDC is nothing but IDC, it is nothing but Im by pi. Im by pi. This is the very important, and this is a very important derivation from the point of examination also. Okay, so now what we can do is we need to calculate the RMS value across the load. So we have calculated the DC value. Now we need to calculate the how much AC signal content is there. So that is nothing but a RMS value we need to calculate. So which is nothing but IRMS into the total resistance what you have left. So since I told you this secondary resistance and forward resistance are very negligible, so therefore we can minimize over the RL. So means what? If it is in terms of kilowatts, kilo ohms, and it is in terms of 1 ohm, 2 ohm, means we can neglect that effect. So therefore, your VRMS is nothing but Im by 2 into RL. So your VRMS is nothing but IRMS, it is nothing but Im by 2. That's now I have calculated, right? So Im by 2 I have substituted RS into RF plus RL. So this RL I have taken as. So therefore what we'll be getting is, so Vm by 2 into RL. So what is this Im? Im is nothing but Vm by RL. So I am substituting in place of Im, I am substituting the value. Im is nothing but Vm divided by 2 I am substituting. So this RL will cancel it out. So the RMS value is nothing but Vm by pi, the RMS value of the voltage, which is nothing but Vm by pi. This is very important. This is very important. Okay, so once you know the RMS values of that, then we can easily calculate the DC power. So I told you, right, DC power is nothing but PDC is equal to PDC into IDC. So either I can use like this or I can use like this, that is I square into R. So what you have said, that is nothing but I square into R. Okay, so what is the IDC value? So what is IDC? It is the average value, that is nothing but Im by pi whole square into RL. Okay, so this is the DC output power across the load resistance RL. Okay, so now I want to see what is the AC input voltage or what is the AC input power. I want to calculate. So what is that? It is nothing but VRMS into IRMS. So I can use like this also, that is nothing but IRMS square into RL. So if I do that, what you'll be getting is RMS, I know that IM by 2 whole square. If I do that into RL, so you'll be getting a AC, that is a AC power which has been flowing across a secondary transformer. We call it as a AC power, that is nothing but IM square divided by RL divided by 4. Okay, so now you got a AC current, that is a converted DC current, and the AC current or the AC power which is flowing across the circuit. So it is something like it is the output what you have converted, that is a DC, and this is the input what you are applying, input voltage what you are applying. Okay, so therefore I can find the efficiency with what percentage the output has been converted. DC, that is nothing but DC output divided by the AC input. If I do that, I will be getting the efficiency. Means how much percentage of AC has been converted. Okay, so that we will be calculating in terms of efficiency eta. So AC is nothing but it is a ratio of, you can see here, DC output power divided by AC input power. It is a ratio of DC output power divided by AC input power. So if I substitute that, that is nothing but PDC divided by AC. So you have a PDC over here, PAC over here. So if you substitute, you can see here IM by whole square into RL. So whole divided by IM square divided by 4 into RL. So this RL and this RL will cancel it out. Okay, and this 4 and 4 will be means this IM square and this IM square will cancel it out. Okay, so you have left with 4 divided by pi square. You have left with 4 divided by pi square. That is the efficiency is nothing but 4 divided by pi square. So if you want to measure in terms of percentage, so then what we should do is, so for this 4 divided by pi square, I need to multiply 100. So if you want to represent in terms of efficiency, so if I do that this, so you'll be getting a 40.06. You'll be getting a 40.06 percentage. Okay, so means what? There is a conversion rate from DC to AC to DC of 40.6 percentage conversion rate is there. Okay, so that is what we can draw the conclusion from this. Okay, so I request now all the students, you please make a note of these equations and all. And if you find any difficulties in understanding these equations, so I'm ready to explain or I'm ready to give the clarifications on each equations. Yes, please make a note of this. So in the yesterday's class, we have learned up to this RMS value. So in the today's class, we have just gone one step ahead. That is, we have calculated the power values, and based upon the power values, we are calculated the efficiency. You please make a note of this and tell me if you completed means, then we will go to the next concept. Yes, make a note of these equations, everyone. Please make a note of these equations. See, it's not that you need to sit idle. So if you do not understand anything means you should ask me. Okay, please make a note of this from here. I think yesterday we have stopped it over here. So from here you make a note of this. Yes, is that over? Taking down this RMS value of the load voltage. Anyone? Can you just respond? Shall I scroll it down, the PDF? Shall I scroll down the PDF? No? Yes?
Yes, sir.
Okay. Please make a note of this. See, definitely in the main examination, they will be asking you derive an expression for efficiency of an half wave rectifier, or they will be asking you show that the efficiency of the half wave rectifier is 40.6 percentage. So if they ask you like this means depending upon the marks how much they have allotted, so you need to derive the expression. You need to derive the IDC value, you need to derive the IRMS value. Based upon that, you need to calculate the DC current, DC voltage, and you need to calculate the DC power and AC power. And after that, if you take the ratio of DC power divided by AC power, you will be getting the efficiency. Please make a note of this, everyone. Shall I scroll it down now? Yes. Shall I scroll it down? Okay. Take down up to here. Is that over? Is it over? No? Yes? Is any doubts in this? Any doubts? Yes, Kusuma is here. Yes, Kusuma is here.
Yes, sir.
Have you noted down the Kusuma?
Yes, sir.
What is the efficiency of the half wave rectifier, Kusuma? What is the efficiency of the half wave rectifier? Kusuma left. Yes, what is the efficiency of the half wave rectifier? Yes, can anybody tell me? Yes.
40.6%.
40.6%. Yes, Monisha, can you just tell me what is the IDC expression, DC current expression? IDC. What you'll be getting? IDC is equal to IM by, what is that value? Yes. What is IDC value? What is RMS value? IRMS value? Can anybody tell me? Yes. Don't know. Yes, Monica is here. Monica. Okay. See, you people should respond it. See, once you respond, then only I will able to come to know whether you have understood or not. So first you should listen it. The first basic thing is you should listen it. If you're not able to understanding means, then definitely I am there for you people to help it out. So if you simply not attending the classes or simply for the sake of attendance, if you are be present in the meeting means, then there is simply a wastage of energy and the time. Please don't do like that. And up to now today whatever I have completed, so that will be there for your internals. Okay. So up to the efficiency of halfway rectifier is there, right? So up to there it will be there. So the remaining thing we will discuss. So some, as Pushkar said, he is facing some problem in understanding the flip flops. So in the next class, that is in the tomorrow's class, we will try to have one revision on that, and we will try to wind up the class. Okay. So all the best students. So write well for the first IA. So if you write well for the first IA means, then you'll be getting a confidence. So I know there are some difficulties for some students. So since you are writing for the first time, right? Online examination, do you writing the first time or last semester you have already written?
No, sir, first time.
First time, yes. Okay, first time, right? So keep A4 sheets ready with you people. Okay, for each subject. So minimum, I think you require 10 to 15 means A4 sheets you require. So you keep it ready with that. Okay, and make sure that you have a internet properly during the IA time. Okay, and try to learn the things, and whatever the assignment questions or whatever the important questions they have given you, try to go through it. And see, they have all the teachers, they have already given you the notes. See, you need to first see what is there in the notes. It's not that directly go on solving the assignment questions. So whatever the assignment questions they have given, so some assignment questions already it has been solved in the notes only. So you can solve by your own and you can cross verify with the notes means, then the job will be completed. Whether the answer, whatever I have solved, whether it is correct or not, instead of that thinking like that. So first you see whatever the problem which are there in the notes which has been given by the faculty member. First you see that, and then definitely you'll be getting the solutions for all the assignment questions. Okay. So I will be taking the attendance from this report only. And see, once we exit from the meeting, there is no necessary for you to join the meeting again. I'm telling repeatedly. So if I leave the meeting now means, then the class has been ended over from here only. It's not that you are not active and again you will be logging and again the attendance report, whatever is there, that will vanish it out. Okay. Is that clear? Is that clear? Any doubts? Yes, other students, any doubts? No? If any doubts is there means, you say you know, and you can exit from the meeting. If any doubts is there means, you be present in the meeting. Yes. Yes, Arpita, any doubts you have?
No, sir.
Yes. Okay, you can exit from the meeting then.
Thank you, sir.
Thank you.